Hello everyone, welcome back to Math with Allison. Today we're working in our curve series, so we're going to be talking about basic polar curves. So let's go ahead and dive into it. Here you can see two of our coordinate systems. So we have the polar coordinate system. That is going to be a point is given in terms of the radius, so the distance from the origin to the point, and also in terms of theta. So that's going to be the counterclockwise angle right from the positive x-axis. Now, here's the coordinate system that we're used to working with. It is our point x comma y. You go over x and you go up or down y, right? So let's go ahead and compare the two of these in order to understand it a little better. So first we can write a function as x is equal to something, right? So here when we have x is equal to 2, we know we're going to stab the x-axis at the value of 2. So this function is going to be a vertical line just like this, right? That is x is equal to 2. So similarly, when we're working in a polar coordinate system, we can have a radius equal to 2. This tells us that it's going to be all angles where the radius is equal to 2. And so this is going to describe a circle with radius 2, right? Just like that. Now, similarly, we can also have that y is equal to some value, right? So when we have y is equal to 1, we know we're going to stab the y-axis when y is equal to 1. It's going to look a function like this, right? We can have any x value, but y is always going to be equal to 2. So we can also have theta is equal to a constant. Here, theta is equal to pi over 6. So if we go to our angle pi over 6, it's going to be any angle like this. It means that we can have any radius, which that also means we have to extend in the opposite direction in case we have a negative radius, right? So it's going to be a line that goes across the angle pi over 6. It's going to be true for any possible radius. So our final type of function is we have y is a function of x or x is a function of y. So here we have y equals x squared. And we can graph it out, right? We know that relationship is going to look something like this, right? We have when x is equal to 1, y is equal to 1 squared. When x is equal to 2, we're going to go all the way up to 4, so on and so forth. We can also have the radius as a function of theta. It's going to be a spiral. So when theta is equal to 0, our radius is equal to 0. So we're going to start at the origin or the pole. Now, it is going to increase according to when theta increases. But theta increases in a circular motion. So the radius is also going to increase in a circular motion. So it's going to look something like this, right? At the spiral. Just going to look like that. So let's go through most of these in detail. So here we have a circle, and the circle is going to be centered at the pole or the origin. That's going to be given in the form that r is equal to some number a. So here, let's take the example r is equal to 3 halves. That's going to be the distance from the origin to the point is always going to be 3 halves, no matter what angle we're at. So if we go at 1, that's going to be 1.5, right? So we're going to go at 1 and then an additional half, and our circle is going to look something like that, right? Thank goodness for that autocorrect because it does me well. So that is going to be the form for a circle centered at the origin. Now, lines are going to be when theta is equal to some value a. That theta value is going to be true for all values of the radius, right? So here, let's take the angle 3 pi over 4. So we need to go over to 3 pi over 4, which is the center guy right there. And we're going to extend for any possible radius, right? Any positive radius and also any negative radius. And it's going to look like a line. Finally, for the spiral, we have the r is equal to some number a times r theta. So here we're going to work with the example r is equal to 3 times theta. And of course, we're going to plug in some values so we can see this a bit better. So let's start off with a theta equal to 0, right? That's our input. That means our radius is equal to 3 times 0, which is 0. So that gives us our first point. We're going to start at the origin. Now, when we have pi over 6, our theta is 3 times pi over 6. So we get pi over 2. And I'm going to use a calculator to get an exact answer. So with pi over 2, we get 1.57 approximately. So now let's keep going for all of these, right? I'm going to do 3 times pi over 2, which is 3 pi over 2. Let's calculate that. 3 pi divided by 2, approximately 4.71. Okay, so now we have pi. We're going to multiply that by 3, right? We get 3 pi. That is going to be 9 something. Yep, it's 9.42. Okay, and now 3 pi over 2, we got to multiply that by 3, right? We get 9 pi over 2. Let's go ahead and see what that's equal to. 9 pi divided by 2. That's going to be 14.14-ish, right? So now let's go ahead and plug in these values. I'm going to say each radius is going to be like a distance of 5. So this will be 5, 10, and 15. So we want to go to our angle pi over 6, and we want to go out a distance of 1.57. So that's going to be something kind of like that, right? Now, our next angle is going to be pi over 2, right? So this angle is going to be pi over 2, and we're going to go ahead and go out a distance of 4.71. So we're almost to 5. Now let's go to our next angle, right? We're going to go over to pi, which is our angle this way, and we want to go out a distance of 9.42. So that's going to be, we're super close to 10. And now one more angle to fill in. We're going to go down to 3 pi over 2, and we're going to go out a distance of 14.14. So that's almost to 15. And now that's where we get the spiral-like look, and it's going to look something like that, right? You can see it. Drew badly, but we get the picture, right? And that's how we get a spiral. So we talked about circles that are centered at the pole or the origin, and we also have circles that are not going to be centered at the origin. So let's go ahead and take a look at what these look like. First, when we have r is equal to 2a times sine of theta, this describes a circle of radius a centered at the point 0a. So let's go ahead and see that drawn out. Here we have r is equal to 4 sine of theta, right? So this point is going to be centered at 0, 2, and it's going to have a radius of 2. Let's go ahead and plot some points to see why that's the case. So here we have our input is theta, and our output is going to be the radius. So here we're going to go ahead and plug in 0, right? And we get 4 sine of 0 is indeed equal to 0. So we see our point 0, 0, which is down here. Now let's go ahead and plug in pi over 2, right? So here we get 4 sine of pi over 2, and we know pi over 2 is equal to 1, so we get 4. So we go all the way up to pi over 2, which is in that positive direction, and we go out a distance of 4. Now let's go ahead and do pi. We get 4 sine of pi. This is sine of pi is equal to 0, so we go back down to pi 0, right? So that's where we get that point again. And here let's just do 3 pi over 2. 4 sine of 3 pi over 2 is going to be equal to -4, right? So when we're going down in that 3 pi over 2 direction, we're going to go backwards because we have a negative radius. So we're going to go back up to our point 40. Now, if you wanted to check extra angles, you're more than welcome to do that. One example would be pi over 4, right? If we were to plug in pi over 4, we get 4 sine of pi over 4. And we know sine of pi over 4 is equal to root 2 over 2. So let me go ahead and plug that into our calculator. We get 2 times the square root of 2, which is equal to 2.83. I'm going to round it. And so this radius right here would be about 2.83 if I drew it better. I don't think that's an accurate angle. Maybe it would have gone more that way. But those are other ways that you can check multiple points, right? So here, when we see sine of theta, we're going to extend in the y direction, which actually makes sense, right? Because we know that if I write it down, that y is equal to r sine of theta. So you can think, when you think of sine, you think of y, right? We're going to extend in the y direction. So that might hint you at what happens when we have cosine. So here we have r equals 2a cosine of theta describes a circle of radius a centered at the point a0. So you can assume that it's going to extend in the x direction. So let's see a photo. Here we have 6 cosine of theta. And so this is going to be a circle centered at the point 30 with radius of 3. If you wanted to plug in points, you're more than welcome to do that. Here we have theta, that's going to be your input, and then we're going to have an output of r. So here, let's go ahead and start off with theta is equal to 0. We get 6 cosine of 0 is equal to 6 times 1, which is 6. So in that 0 direction, we're going to go out a radius of 6. Then let's go ahead and see maybe something like pi over 4, right? Pi over 4, we get 6 cosine of pi over 4, which is equal to root 2 over 2. So that's going to be 3 root 2. And here we can calculate that out. 3 times the square root of 2. We get 4.24, right? And so that would be the distance we went out right here, 4.24. We can go ahead and plug in, let's say, pi over 2. We get 6 cosine of pi over 2 is equal to 6 times 0, which is indeed equal to 0, right? So when we're going up in that pi over 2 direction, we're just going to stay at the origin. So in this case, right, you can also associate it with the fact that x is equal to r cosine of theta. So when we see cosine of theta, we can associate that with x, right? So now for the final couple examples, we're going to go ahead and do some conversions. So here we want to convert r equals 4 sine of theta to Cartesian coordinates, right? So let's go ahead and talk about what we already know. We know that x is equal to r cosine of theta. We know that y is equal to r sine of theta. And we also know that x squared plus y squared is equal to r squared. So let's go ahead and talk about the equation we currently have. R is equal to 4 sine of theta. First of all, I see an r, but I don't see an r squared. I also see a sine of theta, but I don't see an r sine of theta. Notice what both sides are missing. I'm missing an extra r. So what we could do is just multiply both sides by r. Multiply this by r, multiply this by r. This way I get r squared is equal to 4r sine of theta, and now I can plug those in. I know r squared is equal to x squared plus y squared, and I also know that r sine of theta is equal to y. Now, we know this is a circle, right? This is going to be 4 sine theta. We know exactly what it looks like, right? It's this first drawing right here. And so I want to make this look like a circle, right? A circular coordinates. So let's go ahead and get everything to one side. X squared plus y squared minus 4y is equal to 0. We're going to do something tricky here. We're going to complete the square, right? So x squared plus y squared minus 4y plus something, and we also have to subtract that something, is equal to 0. Now, if you don't remember how to complete the square, what we do is we take our middle term, so negative 4, and we divide it by 2, and we square it. So here we get 4, right? We get negative 2 squared is equal to 4. So we're going to add 4, but we're also going to subtract 4, right? Because I can't just magically add something. It's like you're adding 0. You're technically not adding anything because you're also subtracting it. So here we get x squared plus, and this is going to be y minus 2 squared. Whatever value you get in here, so this is negative 2 squared, that's going to be the perfect square that we're working with. So we get y minus 2 squared, and what I'm going to do is I'm going to add that 4 over is equal to 4. And this here we can write out, right? This describes a circle centered at the point that's going to be 0, 2, with a radius of 2. Right? This is going to be the form. We have x minus a squared plus y minus b squared is equal to r squared, right? And the center is going to be at a comma b, right? So that confirms the fact that we're working with a circle centered at the point 0, 2 with a radius of 2. Now let's go ahead and see that with our r cosine of theta. So very similarly, I see an r and I see a cosine of theta. Both of them are missing an r. So let's multiply r to both sides. We get r squared is equal to 6r cosine of theta. I know what r squared is equal to. X squared plus y squared is equal to 6, and r cosine of theta is equal to x. Now let's go and move everything to one side. We get x squared minus 6x. And I'm going to leave a space because we're going to add something and we're going to subtract something in order to complete the square. Plus y squared is equal to 0. So here we're going to take our middle term, right? So negative 6 divided by 2, and we're going to square it. So here we get what? Negative 3 squared, which is equal to 9. So I'm going to add 9, and I'm also going to subtract 9 so that I add 0. And here we'll complete the square. So we get x minus 3, right? Squared, because that's the thing that we end up squaring. And then I'm going to add over that 9. So I still have that plus y squared is equal to 9. And here we can see the circle. So this is a circle centered at the point 3, 0 with a radius equal to 3, right? And so that confirms our drawing right here. We have a circled center at the point 3, 0, and it has a radius of 3, right? This is going to be the point 6, 0. So that is all I have for us today. If you enjoyed this video, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.